Hello everyone, welcome to course study on solid mechanics. In today's lecture, we are going to discuss the numerical based on simply supported beam which is subjected to UVL or combination of point load and UDL. The problem statement is as follows. A simply supported beam 10 meter span subjected to 2-point load of 10 kN each at 2 meter and 4 meter from support A. It also carries a UDL of 5 kN per meter over a 4 meter from support B. Span from support B, draw SFD and BMD. Now, as given in the numerical, we have a simply supported beam which has a span of 10 meters. So this span is 10 meter, is subjected to 2-point load of 10 kN each. So this is the first point load and this is the second point load, which is located at a distance of 2 meter and 4 meter from support A. So from support A, first load is at a distance of 2 meter and second load is at a distance of 4 meter. It also carries a UDL of 5 kN per meter. So the intensity of UDL is 5 kN per meter over the span of 4 meter. Draw SFD and BMD. So we have to draw the shear force diagram and bending moment diagram. Now all of you know that the first step while solving the problem on shear force diagram and bending moment diagram is to calculate the support reaction. So support reaction can be found out by using equilibrium condition. So the first equilibrium condition is summation of f of x equal to 0. But as there is no horizontal force acting over the system, therefore summation of f of x is equal to 0. It will remain 0. Next equilibrium equation is summation of f of y is equal to 0. So we have to sum all the vertical forces and we have to equate it to the 0. Therefore Ra, which is acting in upward direction, therefore consider as a positive. Minus 10 because it is acting in downward direction. Again minus 10 which is acting in downward direction. Minus 5 into 4. So it means that we have to convert UDL into its point load. Therefore how to convert it into point load? Intensity of UDL into length, it will be converted into the point load and it will act at the center of its span. Therefore 5 into 4 will be the point load and that point load will act at its center, plus RB again which is acting in upward direction, which is equal to 0. So it means that the summation of f of y is equal to 0. After solving this equation, we have one equation Ra plus Rb is equal to 40. This is the equation number 1. Now we have third equilibrium equation, that is summation of moment at A is equal to 0. Therefore this 10 kN into perpendicular distance is 2 will be acting in clockwise direction, so will be positive. This 10 kN into perpendicular distance is 4, therefore acting in clockwise, so it will be positive. Now this 5 UDL into 4, it will be converted into the point load. This 5 into 4 will be the point load and it will act at the center of its span. So this 25 into 4 is nothing but it's a 20 kN. Therefore it will be act at a distance of 2 meter over the entire span. Therefore this perpendicular distance will become this 2 plus this 2 plus this 2 plus this 2, so it will be 8. Therefore we have a UDL is converted into the point load and for that point load we have the perpendicular distance, that is 8 meter, and minus RB into 10 because this RB will act in anti-clockwise direction with respect to point A. Therefore minus RB into perpendicular distance is 10, which is equal to 0. Therefore moment of A is equal to 0. After solving this equation, we have RB is equal to 22 kN, and if I put the value of RB into equation 1, I have Ra is equal to 18 kN. So in this manner the first step has been completed. to find out the support reaction. Next step is shear force calculation. So remember that shear force at ends always remain 0. Therefore shear force at left of A is equal to 0. Shear force at right of A will be plus 18 kilonewton because the reaction of RA is 18 kilonewton and it is acting in upward direction, therefore will be positive. Next one, shear force at left of C is equal to again plus 18 kilonewton because in between A to C there is no force is acting, so it will remain constant. Now if I consider shear force at right of C, then we have already 18 kilonewton plus this 10 kilonewton, but this 10 kilonewton is acting in downward direction, therefore we have minus sign because it's an algebraic sum of all the vertical forces. Therefore plus 18 minus 10 will give you 8 kilonewton. In the same manner, shear force at the left of D is 8 kilonewton because there is no force is acting between C to D, therefore it is 8 kilonewton. Now shear force at right of D, we have previous force 8 kilonewton and next force is 10 kilonewton again, which is acting in downward direction, so we have the answer minus 2 kilonewton. Shear force at A, now at E we are not going to calculate at left and right because no shear force is acting at point E, but at point E the UDL start, therefore it will act as a major point. Remember that we have to calculate the value of shear force at E because it's a major point where UDL starts, therefore it can be considered as a major point. We are not going to calculate the value of shear force just left and right of it because no shear force is acting over there. Therefore shear force at E is equal to minus 2 kilonewton because in between D to E again no force is acting over there. Now shear force at left of B will be minus 2 and this point load minus 20. So shear force at left of B is nothing but it is minus 2 minus 20, so it will give you minus 22 kilonewton. And all of you know that shear force at end, that is right of E, will be 0. Right of B, sorry, here it is B, not E, it is B. Shear force at right of B will be 0. So we are going to draw the shear force distribution diagram. So for A it is the 0 value, for the same value of A it is 18 kilonewton. So for the point load we have a vertical line. Now from A to C there is no force is acting, so it will remain constant. Again at C we have another value, that is downfall 8 kilonewton, so it will go down. Again from C to D no load is acting, so it will remain constant. At right of D we have minus 2 answer, therefore it will go down below the 0 line, it will go to the minus sign region, therefore it is minus 2. Again from D to E no load is acting, therefore the intensity will be minus 2. From E to B minus 22 kilonewton. And remember that when any beam is subjected to UDL, in case of shear force diagram you have to join it by an inclined line, therefore you will observe an inclined line for the uniformly distributed load. This is the inclined line and the intensity is 22 kilonewton, minus 22 kilonewton. And again shear force at right of B will be 0. So in this manner we can draw a shear force diagram. Now our next step is moment distribution diagram. So first of all we are going to calculate the value of moment. Remember that bending moment at its end always remain 0, therefore bending moment at A and B is equal to 0. So we have to calculate the bending moment at point C, at point D, at point E where UDL start, and at point F also, because at this point in case of shear force diagram we have to a point load is acting, Therefore we have moment at C is equal to summation of moment at C is equal to 0. So if I consider this 18 kilonewton, it will produce a sagging effect, therefore it will be considered as a positive. So 18 into perpendicular distance up to C is 2, therefore it will give you the value of moment at C 36 kilonewton meter. After that we have to calculate moment at D. Again this Ra will produce the sagging effect, therefore it will be positive. Therefore Ra, that is 18 into perpendicular distance, is 4. Up to this it is 4, and this 10 kilonewton will produce the hogging effect. Therefore we have minus sign, minus 10 into 2, therefore we have 52 kilonewton meter. So moment at D is the algebraic sum of all the moment on any one side of that particular section. Now we have moment at E. Moment at E will be calculated by Ra into perpendicular distance is 6, therefore this one, minus 10 into 4 because it will produce the hogging bending moment, and minus 10 into 2, so the summation will be 48 kilonewton meter. And last one, we have to find out the bending moment at point F. So at point F, this 22 we can consider any side. If I consider right hand side, because from this side it is easy to solve, so I have considered from this side. So 22 into 2 is this one, minus this 5 kilonewton per meter UDL, it is acting over the 2 meter only, therefore minus 5 into 2 and a perpendicular distance, and it will act at its center, therefore it is 1. Therefore we have answer 34 kilonewton meter. And bending moment at B, as discussed to here, bending moment at B is equal to 0. Now we have to draw the bending moment diagram. To draw the bending moment diagram, all of you know that between 2 point load we have to join it by a straight line, therefore straight or inclined line. Therefore at A we have 0 value, at B we have 0 value, at C we have value of 36 kilonewton. So this is 36 kilonewton, and in between these two we have to join it by a straight line. Again at D we have 50 kilonewton meter, again join it by a straight line, straight inclined line. Next one, moment at E is 48 kilonewton, so join it by in this manner, because there is downfall from 52 to 48 kilonewton meter. And again at F we have 34 kilonewton, join it by a inclined straight line, and at B we have to close it, that is 0 value. So in this manner we have drawn the bending moment diagram by calculating the value of bending moment at each and every point. So in the next lecture again we will discuss the numericals based on the SFD and BMD. We will stop here. Thank you.